Hi, everybody. Bom dia. I'm going to speak in English. I'm sorry. I don't know Portuguese, so we're going to talk about the art of PostgreSQL. So the idea for this talk is it's more for developers, application developers, than for DBAs. So who in the room is more an application developer than a DBA? Yeah, that's for you guys. So I hope you find it useful. But there are some bits and pieces that DBAs will like to hear too, so that's cool. So I've been working with PostgreSQL. I began using PostgreSQL in the last century. And I've been contributing to Postgres. So I did a create extension. That's a command I wrote. And event triggers too. I'm currently working at Citus Data. We do a sharding version of PostgreSQL. So you can have a coordinator server and several workers. And the workers are going to have each a piece of the data, some slices. We call them shards. And so you can query the coordinator like it's a normal PostgreSQL database. And actually, we're going to send the queries to several workers in parallel and do things, etc. So it's useful when you have lots of data. Citus Data has been acquired by Microsoft. So I'm now working at Microsoft. And of course, we hire, so have a look. One of the things I do also at Microsoft nowadays is called PG Auto Failover. And I'll go fast on that because we'll see that in a lighting talk later, just after this talk. Another project I wanted to talk about in the intro is PG Loader. The idea is to migrate from another database to Postgres. So if some of you guys are currently using MySQL or SQL Server or maybe SQLite or other systems that are supported by PG Loader, you can switch from, let's say, MySQL to PostgreSQL in a single command line. So that's the real command line that you can type. So you can see MySQL connection string, PostgreSQL connection string, and then PGLoader will connect to MySQL, fetch from the catalogs the list of table indexes, column names, data types, etc. that you're using, reproduce the schema with a default set of casting to PostgreSQL, migrate the data, recreate all the indexes in parallel, the foreign keys, the comments, all of that. So that if you're using MySQL, the idea is you should use PostgreSQL actually, and I'm going to explain you why. And you don't have any excuse. You just run one command line, and you can use PostgreSQL with the same data set. So welcome to PostgreSQL. This talk is mainly extracted from the book I wrote some time ago. So it's Mastering PostgreSQL in Application Development. It's in English. There is currently no translation, so there is no Portuguese version. I'm sorry. But if you like books in English, have a look at this one. So the first question I like to ask developers is, why are you using PostgreSQL? Do you know why? Because in most cases, you just join a company as a developer, and there is an application stack, and you're given some tasks to implement, some new use cases, business cases, something. And you're going to use the current stack. So maybe it's Python, maybe it's Java, PHP, something. And there is PostgreSQL, so you're going to use it. Okay. But if you think about it, what kind of problem are you going to solve in your code with PostgreSQL rather than, say, a Java or Python? So what I've heard a lot when I was a consultant from developers is, well, it solves storage. Well, storage was solved in the 60s, 70s already when they invented RDBMS. So if you're doing Java, for example, serializing an object in Java to XML, it's really easy. And then you can read the XML back into an object in memory. So if the problem you want to solve is storage, you just map your objects into XML, store that into something like a blob, like S3 on Amazon, AWS. They do storage. It's called S3. If you want open source equivalent, it's called the Ceph. So if you want to solve storage, that's really easy. That's not Postgres. So Postgres is a database manager. It solves concurrency and isolation. The reason why we use PostgreSQL is because we have several users using the same application at the same time. and we want the things to work in a coherent way for everybody at the same time. So in your code, you're going to solve one user at a time. And in your database, you're going to solve the problem for the whole system at a time. So that every combination of actions, like ordering items, being delivered, something, etc., you can do everything at the same time, and it all makes sense for the whole business. So that's why we use PostgreSQL. And how do we solve concurrency and isolation with a relational database manager? Is thanks to these things that everybody has heard about before, I guess, ACID. Yeah, everybody knows about ACID? Yeah. So just a quick reminder, what does it mean, ACID? So, oh, and before I do that, the most important thing about ACID, when you know what it means, is to realize, are you using a system that is compliant with the properties of ACID or not? So I like to say bad things about some of the other products that are not PostgreSQL, so it's easy and fun always. So in this case, I will pick MongoDB, because it's, yeah. See, it's already fun, and I didn't begin. So MongoDB doesn't have transactions. So you don't have, it's not atomic, and it's not isolated. So you lose the A and the I in ACID. Consistent, well, it's a schemaless. They call it a feature. They don't know what the data is. They don't know what it looks like. They have no idea what you put in there. So there is no way for them to be consistent with any business rules that you could have to implement. So you lose the C, remains the D, durable. Apparently they fixed that, but it used to be that they were not durable either. So the thing to keep in mind is that mostly when we go in school or when we learn how to program, maybe in school or somewhere else, we are taught to think of databases as something that is compliant with ACID properties. And so when we write code, we don't rethink about that. We don't think twice. We just consider that when we send things to the database, it's going to be ACID. When you're using PostgreSQL, that's fine. Continue that way. But if you're using something else, maybe you need to think, do I have the ACID properties behind me? Or do I need to re-implement, for example, consistency on top of JSON documents? Who is going to check the business rules? If you're using MySQL back in the days, they would accept foreign keys in the syntax, but they would not enforce them, okay? It was on purpose, it's a feature. It means that the application needs to do it. The database is not doing it. So you lose the C of consistency. Is it important for you? I'm not saying it is or it is not. You know your application, you know your use case, you know what you're doing, okay? But you just need to remember that if the system that you are using is not ACID, and you need it, then you need to do it in the application itself. Okay, so it's quite important. Atomic, the main thing is rollback. So usually we don't type rollback on the command line, or even less frequent, we don't implement rollback in the middle of our code. Usually when we do a transaction, we commit, we don't roll back. We don't ask for rollback. But when you commit, it's a command that you send. It's not a guarantee until you have the answer. And the message back should be commit to. You can say commit and then receive a message like no space left on device. Disk is full. There is no space left for registering the transaction. So in that case, you will send commit and you will receive rollback. Okay, that's what it means being atomic. One thing with PostgreSQL is that we have transactions also for DDLs. So DDLs, you see what it is? It's all the commands to define it's data definition language, so to define the schema, create table, alter table. That and atomic, it means that you have an application in production. You have a schema changes. So often we call that a migration. So you're running a migration in production. You have version 1 of the application schema, and then at the end of the migration, you have version 2. Let's say that in the middle of the script, file system is full. It happens. What's next? If you're using PostgreSQL, what's next is rollback, and the application in production is version 1. The schema is version 1. If you're using something else, the schema in production is not version 1, and it's not version 2. It's something that nobody in the developer team has ever seen anywhere. So good luck, fixing bugs with the production system now. So with PostgreSQL, even schema migration are atomic. So that's very good. Consistency is played at several levels in PostgreSQL. For me, it begins with the data type definitions. So again, because I like to say bad things about the other guys, if you have an integer column in MySQL and you insert into it the word banana, it will say, okay, fine, that's, well, I think they say it's 0. So banana is 0, it's the same thing for them. And maybe that's not what you wanted. And consistency means that you have business rules and you want them to apply to every record in your system, in your database. So the first gatekeeper is going to be the data type, and then you can combine the data types to create tables. What is a table? It's just a set. Well, it's a bag. In mathematics, a set means there is no duplicates. But in SQL, we don't guarantee no duplicates. So it's not a set, it's a bag. But yeah, so it's a bag of tuples, so of things that have the same data definition. A tuple, you know what it means, right? The letter T is just a number. So if you have only one element, it's I can't remember the English, but 2 elements, it's a couple, 3, triple, 4 elements, it's a quadruple, 5 elements, a quintuple, etc. So it always ends, the word always ends with those letters, UPLE, so uple. And when you don't know how many columns there is because you're writing in the generic, then it's a T tuple. You're going to have T columns. That's what it means, a tuple. And a relational system, it means that all the tuples in the same table are going to have the same definition. So it's a list of attributes that have this. In each row for this column, it's always going to be the same data type. So that's what it means. So that's consistency. And PostgreSQL is pretty good at that. And on top of it, you can add foreign keys, primary keys, not null constraints, and other business constraints. So sometimes developers will say that business rules should be implemented in the application language itself, not in the database. But I find it that is the wrong way to see things. Whatever you do, you will have some of the business rules in your database system. So the question is not, should I put business rules in my database or in my code? It's, where do I draw the line? How much of it is going to be in the database, and how much of it is going to be in my code? And it's, they need to work together, okay? So you're going to have business rules in your database, because when you create a table with 2 columns, one is integer and the other is text, that's already a business rule. And then in ACID, we have isolation. Isolation is a little more complex to think about than the rest. It's the other side of atomicity. Atomic means, if I say begin, insert, update, commit, either I have the 3 commands that are accepted or none of them. It cannot be a part of it. It's atomic. Isolated means, in between my 2 inserts and my update, will I see what the other guy is committed or not? So for example, if you say select count star in a transaction and then select count star again, and while you are doing that, someone else is going to do an insert. So the count is going to be +1, right? If you're in a single transaction and you do the count twice, will you see the same number or will you see the +1? Well, it depends on the isolation level that you're using. By default in PostgreSQL, it's read committed. So anything that any other guy committed, you're going to see it immediately. But maybe it's not what you want in your application. So one such application is pgdump. When pgdump begins, it takes a snapshot of the whole database system, and it will not see any other insert as long as it runs. If it runs for 4 hours, it will see the same database for 4 hours. It's like in a movie, and you hit pause, so you have a snapshot. The movie is not running anymore. And then you can study the snapshot, and then when you're done, you say play again, okay? So that's isolation. And there are different levels of isolation. So if you're new to the concept, I encourage you to read about the differences and try and understand which one makes sense for your application. Often enough, it's a repeatable read rather than a read committed, but repeatable read is not the default. Okay. And then durable. So durable, do you know this game with the power socket? To know if a system is durable or not, you write a client application. that is going to just do insert, commit, insert, commit, insert, commit. And in the client, you count how many times you got the commit back. It needs to count only when the commit message has been sent back, okay, received back from the server. On the server, you just accept the traffic, and in the middle of the test, you unplugged the power socket. And then you plug again, and you check that the count on the client and on the server is the same. If it's not the same, it's not durable, because you had something that was committed and has been lost. So if it's not durable, maybe it's a mistake in the configuration, maybe it's a fault in the hardware, that happens sometimes, or maybe the software is buggy, or maybe you're not using PostgreSQL, I don't know. So that's why we're using PostgreSQL as developers. It's because we have transaction for acidity. Transactions are going to be A and I. We have rich data types that are going to help us implement good business rules and consistency. So that's the C in ACID. And then on top of that, we have SQL. We have a kind of SQL that is object-oriented, and I'm going to show you more about that. We have extension and other features that we are going to see together. So that was the part more about the background for using PostgreSQL. And now we are going to dive in what happens when you use PostgreSQL. So what happens is that you're going to write a lot of SQL code. So who likes writing SQL query? So my job is to try and convince the other ones. So let's get started. And I'm going to take an example with the data from the New York Stock Exchange, because it's open data, it's easy to download, and it's easy to understand. So it's a good fit for a quick chat like today. So the data looks like this. So you can see that we have, if I do this, yeah, we have several columns. So we have the year, the date, how many shares were exchanged that day in the stock exchange. Then that's the number of trades, and that's the number of dollars that this represents. So we're going to load, it's like a CSV, so we're going to load it with the copy command. \copy means the command is run on the PSQL client. And it's important because a copy in PostgreSQL is not just a command, it's also a protocol, and it's a streaming protocol. So you can stream the data from where it is, like on your disk, on your desktop machine, or somewhere in your infrastructure, and you can stream that to PostgreSQL with the copy command. If you're using PSQL, you do the streaming via using the \copy command. And if you're in Java or Python or your application code, you still have access to the copy protocol. So as soon as you're sending more than one row of the same type, rather than doing insert into like dozens of times in a row, you just open a copy protocol and you stream your data into it. You don't need to buffer the data explicitly in your application. You don't need to generate a huge SQL statement. You just open a copy protocol and you stream the data, that's it. So we do that from PSQL here. And you might realize that we said that the data is text, text, text here, but it's numbers. But that's because in the file here we have commas and currency signs. And PostgreSQL will not accept that as representing a number. So the next thing we do is clean up the data and cast those numbers from text to actual numbers. So here we have begins and numeric. So if you're using money in your database system, it should be numeric. It should never be something else. Because as you saw yesterday, maybe you were in ads talk, if you're using floats, you're going to lose precision, which means you're going to lose money. So don't do that. So who knew you could do a single alter table command, single command, that would rewrite the table only once. And in that rewrite, you're going to change 3 different columns from the old to the new values. And you can use like text processing facilities so that they look like what you want them to look in a single command, 3 columns and a single rewrite. Yeah, so that's pretty cool. It's that's why I did it that way. In modern PostgreSQL version, if I get back a slide, here we could have used copy from program, and we could have used like sed, hawk, or some other transformation program directly to change the data here to something that would be fine for PostgreSQL with the data types, okay? But I wanted to show you that it's pretty cool to be able to do 3 transformations in a single pass in PostgreSQL. If you're using ORM toolings or other abstraction tooling on top of DDLs, maybe you want to make sure that it's smart enough to do it in 1 pass rather than 3, because when your table is like 1 terabytes in production, you know, doing it 3 times is no fun. Something I hear a lot from developers is a complaint about algorithm. They say, well, SQL is not really code because I don't know which algorithm it's going to use. Okay? Maybe you've said that yourself before. So I wanted to have a look at that. Here we're going to pick the 10 days with the most, so that's the date and that's the number of, I can't remember, dollars, yes, that were exchanged in the New York Stock Exchange that day. And we want the 10 days with the most dollars. Okay, that's easy. I wrote the full code in Python on the side. Maybe it's a little too small for everybody to read. But the idea is that we're going to use heap queue here. Heap queue is just that, a heap queue. So you can have only 10 elements in memory at all times. And for each line you read, you're going to replace, if it's going to be a higher number of dollars than an existing line, you're going to replace it. Otherwise, you drop it. Which means that even if you have like several millions of lines of lines of data to parse, you will only have 10 lines in memory at all times. So you can be pretty sure that you're not running out of memory doing this. So how do you write this algorithm in SQL? I guess everybody knows, but here is it. That's quite simple, right? What we did in Python is just order by dollars, limit 10, that's it. So now, how do I make sure that I'm actually using the same algorithm, the smart one, that allows me to keep only 10 lines in memory at all time while I'm streaming through the data? Well, when you ask yourself those kind of questions in PostgreSQL, you use explain. So my favorite version of explain is with analyze, verbose, and buffers. Be careful when you do analyze, you are actually running the query. So if it's a delete, you're losing data. So that's why you do begin, analyze, and then roll back if it's an insert or an update or a delete. Here it's a simple select, so we don't really have that problem. And you can see in dark here that the sort method that has been used is heap sort, right? You even have the amount of memory that has been computed by PostgreSQL to do it, etc. So heap sort, it's exactly the same algorithm as what we saw in Python before. So rather than writing the full thing in Python, or if you're using Java, I'm sure that Java standard has a heap sort kind of facility, or Ruby or PHP, whatever you're using. So rather than figuring out the standard lib and how to use it, etc., you just write order by limit 10, and PostgreSQL is going to be happy to do the heap sort for you. The other advantage is also that when you do it that way, of course, you're going to only spend like 10 lines of result on the network rather than the whole table and then sort it in memory on the client side. And so everybody is, if you have 1 million lines in the table, do you want to fetch 1 million lines in the network and then sort it in your application code compared to doing the same algorithm where you have the data and then fetching only the 10 lines that you are interested into? Okay, so that's the way I like to think about SQL. It allows you to be smart about those things. So that was pretty easy, right? So maybe we have some more interesting questions around the data. Usually when you have that kind of data, the next thing is maybe the marketing department is there and they ask you for monthly reports. So that's pretty easy. This one is the monthly report in SQL. So it's easy, and I'm using Tuchar with some nice displays, but otherwise it's pretty much what you expect. And here you can see that I'm using pSQL, so I'm setting a variable to a value, and then I'm using the variable again. So if you didn't know you could do that, you don't need to resort to Python or maybe Bash or something else just to be able to interpolate a value within a script in SQL. pSQL is good with that already. And the other thing to notice is here, of course, because we want 1 month, I'm asking PostgreSQL for 1 month of data. I don't have to compute myself the size of the month, etc. For example, it's February and 2017. So how many days do we have in February? Well, PostgreSQL knows, so we don't have to answer that question. We just say PostgreSQL interval 1 month. So how long is interval 1 month for PostgreSQL? Well, if you just select interval 1 month, it's 30 days. But as soon as you attach it to a timestamp, then PostgreSQL is going to look at the calendar and gives you the exact number of days for that month in the calendar. So that's why also I said that PostgreSQL is a kind of object-oriented system, because here the greater than and smaller than, and also the plus, the behavior of those operators depend on the data types of the objects that are around them, like polymorphism in Java or in Python. When you call a method in Java, the implementation of the method depends on the real types of the parameters. Well, in PostgreSQL too, the plus, if you do this, 1 plus 2 is going to be adding 2 integers, but here, date plus interval is going to look at the calendar to know that how long the month is, and then et cetera, et cetera. So anyway, here is the result. I'm not sure how interesting it is, but it's just so that everybody is talking about the same thing. Though it's a little interesting because there is one bug. Can you spot the bug? It's not easy because it's at the very last line of the slide, and it's the one line that is the hardest for you to go read. But you might see that we only have 19 rows. So we don't have all the days. If the marketing department asks for a monthly report, usually they want every day, even if you had no activity that day, right? So let's fix that problem. Well, we did it in SQL, but now it's getting complex, so maybe we need to do it in the application code instead. Before I do that, maybe who knows how to fix that in SQL, like adding the days with no activity? Okay, so maybe that's why the other guys you didn't like doing SQL. Yeah, so let's have a look. So that's how to do it in Python. And you might see that we're going to store the result of the same query as before in a hash table. They call it a dictionary in Python, but it's the same thing. And the key is the date. And here we are going to iterate over a month and see if we have the date in the data. And if we have it, we take it. If we don't, we replace with zeros. Okay? That's very simple, right? And here is the result. Again, not very interesting, but we see that we have 20 lines back, and we have the zeros where there is no activity, mainly the weekends. Any questions up to there? No, that's cool, yeah, okay, good. Before we see about is it possible and how to do it in SQL, maybe a good question to ask is, how much time will you have to implement that again and again? If it's going to be used only in one place, like a quick script or exploratory thing, maybe you don't care, but maybe you have an application stack with PostgreSQL and many other bits and pieces. Like in a complex enough application, you have the front end, the back office is maybe using a different stack, and then there is the finance department, and maybe there was this guy doing PHP, and he fixed the problem for the finance very quickly in PHP, whereas the rest of the stack used to be Java, and now it's more Python oriented. And then there is the accounting and invoicing and things like that. So we all have companies with different history. So maybe the stack is a little complex. So maybe it's interesting to be able to solve that problem in SQL so that it's solved for everybody, because everybody is using that guy here, PostgreSQL. Okay? So if we can solve it in PostgreSQL, it means that we solve it once for everybody. So I'm not saying it's the best way to do it. I'm just saying it's an option. But if you don't know how to write the SQL, it's an option you don't have. If you know how to do it in SQL, it's an option you have. So let's see about that option. So let's fix the bug. Like I have the days with no activity in SQL. Here is the query. First thing to notice, what is that? It's a command. Because SQL is code. So of course, when you have code that you're writing for the first time with a new concept that you don't know, of course you add commands, right? And also when your colleagues are going to review your pull request or merge request or just review the code, of course having comments is going to help them a lot understanding what's happened. So what's happening here, we're using generate series, which is a nice feature of PostgreSQL, which does exactly what the name implies, because PostgreSQL is pretty good at being pretty obvious about what's happening. So it will generate a series of data. generate series. Starting from the first date and with a step of 1 day, interval 1 day. And the last date, this time we compute, if we say interval 1 month, it's going to include the next month. But we don't want to do that. We want to stop in February, not going to March. So instead we say, go up 1 month, minus 1 day, please. But remain in February. Whatever the number of days you have in this February that year, stay in February, don't go into March. So that's easy, right? Don't compute that in your application, that's useless. PostgreSQL knows how to do that. And then, the other thing is the left join. So here, the generate series is going to do like in Python before, you know? You generate the calendar, and for each row in the calendar, each date, you're going to see, do I have activity to join it with? And then I'm going to take the activity. And if there is no activity, I'm going to use 0 instead. And use 0 instead is in here. You can see coalesce. Coalesce is a function that is going to return the first argument that you give it that is not null. So in that case, the left join is going to generate null entries for you when there is no activity. And the null entries are going to be replaced with a 0 instead, because it's numbers and we know it, and maybe your reporting with nulls is not as useful for people who want to copy-paste in Excel or something else, compared to having zeros, so you replace with zeros. And that's the answer, copy-pasted from PSQL, so I think it's fair to say that we solved the bug. So any question you might have about generate series, left join, this kind of query, or no, something? Any question? That's good. So we're going to continue because this SQL we saw here, it's not even interesting. It's like, we're not even to the 101 level of SQL. SQL is way more interesting than that. Once we have that, usually the marketing department, one of the things they love to have is some form of it, the week-on-week evolution. It means, let's look at the result. Here, it's a copy-paste from PSQL, but with some colors. So here you see it's a Wednesday, and it matches with the Wednesday for the previous week. And here again, same color. And you can see here, it's the difference in percentage. So this Wednesday did 10% less than this one. Okay? Everybody understand the data set? Yeah, you can see here with the colors. Yeah? So that's easy, right? Who knows how to write a single SQL query that gives you this result? Yeah, that's why you don't like SQL. So let's have a look at it. And it looks a little more complex. So I'm used to say that if it fits on a single slide, it's not a complex query. But here, I admit that I picked a smaller font, and I'm using 2 columns, otherwise it doesn't fit. So if you want to say it's a little complex, I'm going to have to agree. It's in 2 parts. So on the first part, it's a with query, so a common table expression. We're going to fetch some data and reuse it. In SQL, we think in terms of relations. So any query that you do is going to return a relation. And then you can combine relation and do things with them, like joins and set operators like union or except, etc. So in SQL, we play with relations. And if you look at the documentation for the from clause, it's here. From doesn't say that it's going to get data from tables. Tables are just one of the multiple kinds of relations that we have. From is saying that it's going to read data from relations. And so a relation can be the result of another query. So here, we have a relation here, and a query that, if you want the data from this relation, it's the result of that query, okay? And the query on the left, it's exactly the one we saw in the slide before. Almost exactly, with a little subtlety. And here, we are reusing the result and computing a percentage. So the main difference with before is here, we have a window function. So who knows how to use window functions in SQL? Yeah, nice. So for the other ones, sorry about that, it was invented in '92, okay? Same as, I don't know, Unicode, IPv6, things that are pretty common nowadays. Everybody knows how to do that. So window function is the same thing. So actually, it's been in PostgreSQL for less time than that. It was in 8.4, so I think it was something like 10 years ago now. But anyway, anybody who is using PostgreSQL in production nowadays you have window functions and you can use them. So this window function here is lag. Lag is the function, and lag allows you to see the one before. Okay. And the window is here. It's the over clause. So how do you understand that? It looks complex, but the thing is, you will attribute to any row in the result set. You can pair it with peers, friends. So you can define who is going to be my friend. So when I'm looking at one row in the result set, I have access to data from other rows, the friends rows. So who are my friends? In that case, the friends are rows that have the same partition by property, and we are going to see them in the order by ordering. Okay? The partition by is extract iso_do from date. So what is iso_do? Do you know? Do is day of week, yes. And of course, is the first day of the week the Sunday or the Monday? Is Monday 0 or 1? Or Sunday is 0 maybe, etc., etc. So there is an ISO standard for solving that. So I can't even remember what the ISO standard says about it, but we're going to use it, and we're going to assign a number to every day. So Wednesday is going to be, let's say, 3. And so the peers, the friends row that we can see, if we are currently on the Wednesday row, we are going to see every other row that is a Wednesday, because we say partition by any other row that has the same partition by, the same extract iso_do from the date. Any question about that? It's clear enough? Okay. So you define the window with the partition by clause, and you see them in the order, which allows lag to say, I'm going to pick the value from the week before. I lag one position in the ordering of all the Wednesday. And when you do that, then erase the result again. So now you can compare the current value in the row with any other row in the result set. So when marketing is like, we want week on week, and then as soon as you do it, they're like, oh, what about month on month, like January the 15 compared to December the 15, and what about the same day last year, etc. And if you don't know window function, it's not fun to solve that in the application, and it's slow and it's buggy, etc. And if you know window functions, you just change that clause and it's over with. And that's SQL from 92, and the current SQL standard is from 2016. And standard, the SQL standard, it works that way. Any new standard that is published makes any other one obsolete. So there is nothing relevant at all nowadays about SQL 92 or SQL 2011 or other SQL standards, except that they're in the past and they're obsolete, and the current one is 2016. So usually what happens is they keep adding things and they don't change the semantics of before. So whatever you learned before continues to apply usually. But in most cases, when we learn SQL the first time, we are exposed to SQL 89 or SQL 92 for the most lucky of us. But many things happened in SQL in between, and PostgreSQL has most of it. We're still lacking some of the new things from 2016, like match recognize clause or things like that. But SQL is moving fast, and when you don't like SQL, of course you're not looking how fast it moves, and of course you don't realize everything that you can do with it. But it's also why you don't like SQL, because you don't realize how powerful it is. So I encourage you to have a look. And if you want to have a look, you need to be able to think in SQL. So as we said before, to think in SQL, you need to think in terms of relation, because that's what you manipulate in SQL. With the select clause is called the projection clause, and it defines the type of the relation, so the domain attributes, they say in the relational model. In Unix, for example, they say that everything is a file. So if you want to print a piece of paper, you cat to /dev/printer, and that prints a file. In Java, they say everything is an object, but then again, in the documentation, first entry is the normal types, and second, objects, because integers are not really objects. But anyway, they pretend that everything is an object in Java. In Python, you have many things to think about. And in SQL, you need to think in terms of relations and then playing with relations. So as we said, we have select. And from allows you to play with other relations. And to play with them, you have joins. So I guess everybody knows about inner and outer joins. So I will not detail that. The left join we saw before is an outer join. Okay. Maybe you know about lateral join too. Again, that's something from way in the past. So it's very useful when you know it, and when you don't, it's really hard to solve some problems in SQL. So have a look at it if you don't know it already. And then we have union, except, intersect, other ways to play with relations. So for example, if you are writing unit test, except is a good way to see if the expected result is the same as the result you actually have, because you accept the two of them, and the result should be empty, and if it's not, it's the difference in between the two result sets. Here is a SQL query with in which I tried to put in bold keywords that are related directly to relations. Okay? So let's have a look. Of course, from introduces relations. With is a city, so decades here is going to be every period of 10 years, you will have a single entry. So basically, this query is running through all the results of the Formula One's races in the world ever since it exists. I picked that because it's, again, open data. It's easy to understand, but everybody knows about a race where there is a winner and the second position and the third position. Normally, everyone knows that. And so here we are going to pick the top 3 drivers by number of times they won a race for each decade. So the 50s, the 60s, the 70s. So this is going to be like, for example, the 50s. And then we are going left join lateral. That's another way to play with relations with a subquery here that is going to say the top 3 here, order by limit 3. So the top 3 for this decade, and etc. So the topic here is not really that query. Here is the result in case it's difficult to understand. So you can see here the result, top 3 drivers per query. And yeah, we see one Brazilian guy in the 80s, Ayrton Senna. And so Fangio, if someone told you're driving like a Fangio, he used to be the world champion. So you might think it's a good, in France it's pretty common to say that, and people are quite proud of it. But actually when they say that, it's because it's the guy who broke the most number of cars. So it's not really a compliment. But anyway, so any question about that query with the angle, not how does it work exactly, but what is a relation and how you play with relation in SQL, and the fact that we have subqueries is a relation, and then you do a join, lateral join with it, and you produce a new relation, and then you have a with clauses that is producing yet another relation that you can reuse, etc. Any questions? Oh, it's good. We knew how to do this query with or without the left join lateral. Did you know how to do that in a single query statement? Yeah, again, before you say that, I don't like SQL too much, try playing around with it more. It's very nice. And so another thing I want to say today is that SQL is code, right? And if you compare it to Python or Java or some other languages, you're going maybe to say that there are some big differences. And I hear you. Some of the differences are related to the tooling, because if you're comparing it to other programming languages, the other guys, they have automated testing, integration with their code editor, and the pull request systems and the unit tests and everything. Do we have that in SQL? So on the left here, you have just a reminder of what it looks like to write a SQL query, and I made it fit in the slide to pretend it's simple. And the idea around it is to say, if you begin to play with that kind of SQL queries, do you really want to be building the query by concatenating strings in your code in the middle of a Python or Java code file? No, I know I wouldn't do that. So maybe that's another reason why people sometimes don't like SQL, because it's going to be really hard to produce that as a string in the middle of another language of code. So maybe we should have SQL queries in files that are .SQL and that are easy to manipulate. And when you open them, well, you have all the syntax highlighting and all the help that you need to be able to work with the query. And when the query is not very behaving well in production, and you can go to the DBA and say, and send him a link to your GitHub account or something with the query and say, I have a problem with this query, can you help me fix it? And they will be happy to help you and send you a pull request that changes the query to something that is better for production. See, so now collaborating with the DBAs and the developers, it's really easy if the SQL queries are each in a file. And if you do that, it's also easy to do unit testing. So how do you do that? Before we answer that question, it's the only slide where I speak about ORM. ORM is known to be a complex and complex topic, and some people like it, some people don't. I like SQL, so I don't like ORMs. And I think they made a huge mistake. We said that the relational model, the base of it, is that any SQL query is defining a new relation on the flight. If you are running a SQL query, you are defining a relation and fetching its data, right? And it's a new relation. So what you should map in between your object and your relations, it's the result of the SQL query. Because the result of a SQL query is going to be a collection of tuple, collections of objects that are known to all have the same properties and the same object definitions, the same number of columns, and each column of the same type. Exactly like an object with different slots or members or whatever you call them. And you have a collection of objects all of the same type. I'm pretty sure whatever your favorite programming language is, you know how to manipulate a collection of objects of the same type, right? It's pretty easy. Everybody does that every day. So we should map the result of the SQL query back into a collection of objects. And anything else is crazy, is going to be a lot of problems. So most of the ORMs, they don't do that, and then they claim it's a very complex problem to solve. Of course, they didn't understand what is SQL, and they're trying to solve it anyway. So that's my view, personal view on ORMs. So another way to integrate SQL with your code is using something like SQL. So SQL is a pun I really enjoy. I like it. I used it a lot myself. It's a reaction to NoSQL. Some people have NoSQL, but with PostgreSQL, we have better than that. We have YesSQL. Okay? Yeah. So SQL is a library in Clojure that allows you to do something like this. So in Python, it's called AnoSQL. I've been told that in Spanish, it sounds very bad. I'm sorry about that. I don't know what it means. They wouldn't allow me to know. I hope it's not the case in Portuguese. And what you can do is you have a SQL file with queries and comments, and the library will transform those queries into function calls. So then you instantiate it that way, here. And basically, when you do load queries, then you have an object that publishes all the queries as function calls. And then in your code, you can do function calls with parameters and fetch result. That's the result of running the SQL query that is extracted from the file. So that in your source code, you have a .SQL file that is really easy to maintain with one or maybe several queries, depending on what you're doing. When you have those multiple pages SQL queries, maybe you have only one of them per file. And then it's really easy to use them in your code. And it looks like an API. It looks like a function call. You have like a magic object with a lot of methods, and each method is actually mapped to a SQL query. It cannot be more simple than that. And the result, of course, is native objects in your programming language. So it's a collection of objects of the same type. It's a relation. Okay, so it's easy to do. And when you do it that way, then you can copy. This is what I did here. I redid exactly what we have in PostgreSQL source code itself in the regression testing facility. Basically, you run a query, and you register its result. Then you run the query again, and you compare the result from what you registered before. So that when you change the code and you run your test, you can compare that it's still the same result. With the same data set, it should be the same result set. So that's unit testing 101, right? That's the first thing you do when you do unit testing. And I spent like, I think it was a couple of days before, because it was an excuse for me to learn Go. I didn't know Go at the time. So if you're doing that in Java and you're a Java programmer, or Python if you're a Python programmer, my bet is half a day of work to get something like PostgreSQL, where you can have files like this with like parameters for the queries, the output, and the expected output, and you can compare. And as soon as you use diff, like just diff on the two files, and if diff is not silent, you have a problem. You need to fix it. So you have regression testing for SQL. Very easy. Any questions? I have some minutes left, and maybe 10 slides, so I'm going to be very fast for the last slides. But the last section of the talk is about opening even more the use cases for PostgreSQL and SQL, and showing you more examples of some of the magic things you can do in pure SQL. So excuse me if I go too fast, but the slides are going to be published, and you will be able to have a look later. So one thing you can do in pure SQL is geolocation. So there is this database, Geolite, which is free to use, with the conditions that you must say that it comes from the company MaxMind. So because I did it, now I'm free to use it. Okay. So Geolite, and you have blocks and locations. And you have an IP range. And you have this operator that is a little hard to read when you don't know it. But if you think about it, the first time you saw equal sign or greater than sign, you didn't know how to understand it. Someone needs to explain that to you the first time. So it's the same. So you read that contains. So we're trying to find some data where the IP range contains this IP address. And this IP address, I think it was from Google. Let's see in a minute. And, oh no, I don't have the answer. But one important thing to note is that is the schema for the Geolite blocks table. And the blocks table is an IP range. And the IP range is using the data type IP4R. Do you know about that thing, IP4R? Yeah, most of you don't. It's awesome, and it supports IPv6, despite the name. The name is historical, and they added IPv6 support, of course. And so a single IP4R data is going to be a range of IP addresses, okay? Maybe a /24, or maybe just a couple addresses or something like that. It's a range. And in PostgreSQL, we can say that we exclude the ranges with this operator that is, you need to say it, the name is overlap. So we're going to say that if we have two ranges that overlap, well, the second one, we exclude it from the data. You're not allowed in this table to have ranges that overlap, okay? Which means that now when you use them that way, you have a guarantee that this query here, the top query, which is a copy-paste from the previous one, how many IP ranges can I have with these IP addresses when I have a strong guarantee that there is no overlapping in the ranges? There is no two ranges with the same IP address. So if I have one IP address, I will have only 0 or 1 range that contains this IP address, right? Which means that I can do here a cross join. And basically in a single query here, so that is the IP address of the hotel we were in at the conferences in Dublin when I did this for the first time. And we're going to find all the pubs that I loaded from the OpenStreetMap project that are nearby the hotel. So it's the query when you're thirsty. And here you have the 10 pubs closest to the hotel where we had the conference. And you can see it's Dublin because it's not very far away. They have lots of pubs. And here, the order by limit, it's called KNN. NN means nearest neighbors, and K is the number of them. Here it's 10. And PostgreSQL, if you have an index, is going to solve that all in a single index scan. So it's very fast. I don't have the timing, but on my laptop at the time, it was running in less than 3 milliseconds, which gives you all the time you need to then have it on a layer, on a mobile, or maybe a web interface. Okay, so I'm not good at that. I know to write queries. I don't know to write nice mobile apps. So please do the mobile app. Here is the query to find the pubs around you. And there was another example, but I'm going to go very fast. It was from MongoDB again. They just implemented at the time analytics queries. So we call them in SQL aggregates. And some other guys, they call them MapReduce. but basically it's an aggregate. We had that. We've been having that in SQL for 40 years. And they published an article where they say, oh, it's interesting because blah, blah, blah. And when I read the blog post, I was like, oh, what's interesting is that they're very proud of their new engine for aggregation, but they didn't show the query. So I loaded the data from MongoDB into PostgreSQL, and I redid the query, but this time in SQL, of course. So it's a simple enough query. Here, we're going to find basic data. So in that case, it's the number. Have you played basketball before? So maybe you know what is a defensive rebound. So you're trying to score, and you lose, and the other guy you miss, and the other team is going to pick the ball from you. And usually, the team that is very good at stealing the ball from the one who missed is the winning team, the team who wins the match. But they said it's interesting. It happened once that the team that was very bad at this still wins. And well, actually, it happened 4 times. So I don't know. Maybe don't use MongoDB if you have statistics to do. I don't know. And here we have all the games in the whole NBA history where this happened. So the guys are very bad at stealing the ball when they miss the other team, and they still win the game. Okay. I don't know if that's interesting for you, but it was an excuse to do some nice SQL. And the last one is a histogram. So I don't have much time. I'm going to say it's MVC, model, view, controller, and it looks like this. So if you have a quick question like at lunchtime and you want to see the distribution of data, you just do a little, here the repeat that character for that much time. It's you can see 30 here. It's because I don't have that many room on the slide, so it's how many columns I'm going to use in the slide. And then I use a width bucket here, which allows you to say how many buckets you have in a histogram, and if it falls into the bucket or not. PostgreSQL is going to compute that for you, and then you can draw something like that thanks to Unicode. And it's a copy-paste from the PSQL console, so you don't need some fancy JavaScript visualization library, just PSQL, and that's it. Do we have time for questions? Maybe not. Yeah, there is a question over there.
Nosso tempo. Alô? Alô? Pelo nosso tempo tem uma pergunta.
Thanks for the talk. Do those queries perform well and have good instance usages and everything?
It's a good question, yes. Thanks. Well, it depends on many things. The first thing is the size of the data set. So in that case, for example, there were not that many games in the ABA history. So it's a very small table. It runs very fast on the computer, even on my laptop. But then it depends on your prediction volumes, and then the indexing strategy, and then basically almost anything can be made fast enough. And when that's not the case, you can always materialize the result and reuse it. So we didn't speak about performances in that case, but I would argue that first, answer the question, is it more interesting for you to do it in SQL or in your usual application code? And to be able to answer that question, you need to know that it's possible to do it in SQL. And then if you do it in SQL and it's not fast enough, go see someone who is good at SQL and they will help you. Because SQL is a little more complex than it looks. So for performances, it's yet another level. Yeah. So we don't have time for other questions.
Yeah. No, well, just one. Or one. Mais uma questão? Mais uma? De bandeja, assim, ninguém quer? Tá bom, então. Muito obrigado, thank you.
Thank you.